Let's get this going. So if you did the homework that was due today, you already did some problems like that, but I want to start by warming us up with some of those same types of problems. We're finding a product here. So we are going to be distributing or multiplying. So just to remind you what this looks like, I have one term on the outside of some parentheses, and on the inside of those parentheses, I have two terms. What I need to do is I need to multiply the term on the outside by everything on the inside. So we usually draw some arcs up above to remind us that we're doing that. For this first one, I'm going to write out my steps, but after this, I won't write out my steps. But just for one, let's go ahead and write out some steps. So I'm going to do 5x times 8x plus, and then I'm going to do 5x times 3. I did. That's what I get for trying to talk and write at the same time. Thank you for correcting that for me. So 5x times 8x and 5x times 3. Normally I wouldn't write that out, but since it's the first one in our notes, I think that's a good idea. Let's go ahead and do it. What is 5x times 8x? Focus on the 5 and the 8 first. 5 times 8 is 40. And do you remember what x times x is? X squared. Then I have a plus. And then I have 5x times 3. 5 times 3 is 15, and there's an x in there, so 15x. And that's it. That's our final answer. If you're feeling pretty confident with these, feel free to ignore me and go ahead and do the next 3 problems. If you think it would help you to watch a couple more examples and stick with me on this next one. All right, number 2. This time I have 3 terms inside of my parentheses, so I'm going to need to multiply 3 times. Each time I will be multiplying by 3a squared. And to help me out here, I am going to put an exponent of 1 on that a on the inside. So this time I won't be showing extra steps. I'm just going to do the work in my head. So focus on the first term here. And focus on the numbers. 3 times 5 to start. 3 times 5 is 15. And then I've got a squared times a squared. Remember, when you're multiplying, you add the exponents. Exponents get added. 2 plus 2 is 4, so that would be 15a to the 4th. Inside the parentheses, we have a minus, so we'll bring that over here. All right, multiplying the 3a squared times 3a. So 3 times 3 gives us 9. And then a to the second times a to the first. Remember, when you're multiplying with exponents, you add the exponents. 2 plus 1 is 3, so 9a to the third. We have another minus here, so we'll bring that over. And then last time around, 3a squared times 5. 3 times 5 is 15. A squared, there's no other a's to multiply that by, so I'll just bring it over. So 15a squared, and that's it. Any questions on those first 2 examples? If you're feeling pretty good about that, go ahead and work through problems 3 and 4. I'm going to silently work through 3 and 4 as you're doing that. So if you need a hint, you can look up here. Try and do as much as you can on your own though, okay? I would recommend not starting on 5 unless you've seen this before. This number 5 is probably going to be new for most of us. Okay, we should be getting pretty close. Check your answers against mine. We're about to move on to something that's probably going to be new for most of us. We're going to begin factoring today. So chapter 8 is mostly about quadratics and factoring. And the gist of the problems from 5 to 8 is we are going to basically do the exact same thing that we just did, but in the reverse order. So the problems in number 5 looks a lot like the answer for number 3. Our answer for number 5 is going to look a lot like the problem for number 3. Okay, so we are factoring, and that's kind of the opposite of multiplying. So let me show you how this is going to work. I'll tell you that this is going to have a lot to do with our math facts. So if you've got good, solid math facts, this is going to go a little bit easier for you than those who don't. So when I say math facts, I mean, like, do you know what 7 times 8 is? Or do you know what 42 divided by 6 is? Those kind of things. So if that's a little bit weaker for you, the good news is you're going to get lots of practice as you're doing these. Bad news, it might take you a little bit longer than somebody sitting near you who's got a good firm grasp of that. Okay, so let me show you what the answer to number 5 is going to look like. It's going to have a term in front of a set of parentheses. And since I have 2 terms in my original problem, that means there are going to be 2 terms inside of my parentheses. And since this is a plus, I know it's going to be a plus inside of my parentheses. Now, before, when we were going the opposite direction, we were thinking about multiplication. And this one, we're going to think about division. So this is the trickiest part of this whole process. If you guys will look up here for just a moment, I want you to look at the numbers in our original problem, 56 and 16. Can you think of a number that I can divide both of those numbers by and get a whole number answer? They can both be divided by 2. That's true. What else? I heard something else. They can both be divided by 8. They can both be divided by 4. They can both be divided by 1. Everything can be divided by 1, though. So we've made a pretty good list. They can both be divided by 1, 2, 4, or 8. We always want to do the biggest number that everything can be divided by. The biggest thing that 56 and 16 can both be divided by is 8. So we'll write a little 8 down here. So we are going to factor out that 8. That 8 is going to end up living in the front of our final answer. And it has a special name. It is called the GCF. Does anybody know what GCF stands for? Greatest common factor. Nice. So you've seen this before, huh? Good for you. So that's our GCF, because it was the greatest thing that we could factor out or divide out of both 56 and 16. Now, all we need to do is divide. What is 56 divided by 8? 7. And you see how this had an n in it? This 56 had an n in it. We should probably put an n in here with that 7. And what about for our second term? What's 16 divided by 8? 2. And I think that's my final answer. Let me show you how I'm going to check, though. If I were to distribute, if I were to multiply this out, is this the answer that I would get? 8 times 7n is equal to 56n. Yes. 8 times 2 is 16. Yes. Check, check. Cool. That means that's it. That's our answer. So it's kind of like we've started with the answer and we have to work backwards to find the problem. All right, let's work through a couple more of these because they do get a little bit trickier when we have some more variables involved. So number 6, we'll start it off the same way. I know that my answer is going to have some GCF in front of a set of parentheses. And inside the parentheses, there will be the same number of terms that I started with. In this case, it's 2 with a plus in between. So start by looking at the numbers, the coefficients. We got 7 and 21. Can you think of any numbers that divide into both 7 and 21? 7 goes into both of them. Anything bigger than that? You can't divide anything bigger than 7 into 7, can you? So 7 must be the biggest. So we're going to put a 7 underneath of them. We'll put a 7 out in front, but that's not all that's going out front. Leave a little bit of room next to that 7. Because in this problem, both of our original terms have x's in them, which means we can divide out some x's also. Now this first term, I could divide out a single x, or I could divide out 2 x's. And the second one, I can divide out 1x or 2x or 3 x's. What is the most number of x's that I can divide out of both of them? 2. I can get 2 out of this one. That would get rid of all of them. And I can divide 2 out of this one. There would be 1 left over for this one though, right? So the most x's that I can divide out of both terms is 2 x's, or x squared. So that means x squared is also a part of our GCF. All right, so let's figure out what we would have left over inside here. So what is 7x squared divided by 7x squared? What do you get when you divide something by the exact copy of it? You get 1. What is 21x to the third divided by 7x to the second? Focus on the numbers first. 21 divided by 7 is 3. X to the third divided by x to the second. Remember, when you do this, that's 3x divided by 2 x's. You'd cancel those x's top and bottom. You would have a single x left over. We think that's our answer. I'll come to you in just a second. We think that's our answer, but let's double check. Remember, to double check, we can just do a quick mental multiplication. Can I multiply this out and get our original problem? 7x squared times 1 is 7x squared. 7x squared times 3 is 21x to the third. Yes, that's it. So that's our final answer. Okay, thanks for your patience. What's your question? If you multiplied it out, would you get the same original thing that you started with? There are some other techniques to do it, but this is the answer you should come up with. So you could not do this, for example, and end up with a 3x out here. The 3x has to be inside the parentheses with the 1. Now, some people might put the 7x squared at the end rather than having it at the beginning. That would still be correct. Some people might flip the 1 and the 3x around, but they both need to be on the inside. So there are other ways that you can write an answer that would be correct, and there's other techniques you can use to get there. So if you've got something else you think works, I'll take a look at it in a minute. But the big thing is, can you multiply it out to equal the original thing? And is this the biggest thing that you can have on the outside? That's a great question. Hey, I want to ask you guys, why did we not have to take any n's out in this one? In our second example, we had x's as part of our GCF. On our first example, we did not have any n's as part of our GCF. What's up with that? Because in the original problem, you nailed it, and thank you. Because in the original problem, only one of our terms had an n in it. They didn't both have n's. Okay, so the reason we couldn't take an n into our GCF here is because only one of our terms had an n. One of our terms did not have any n's that we could divide out. The reason we had an x in our GCF here is because all of our terms had x's in them here. So look at number 7 with me really quickly and tell me, are we going to have an x in our GCF for number 7? Yes or no? Does every single one of our terms have an x in it? No. So what's that mean? Are we going to have an x in our GCF? Answer is no. Let's go ahead and set this one up. This time we're going to have a GCF, and we should have 1, 2, 3 terms on the inside. First one's going to be negative. Then we'll have a plus, and then our second one, and then a minus, and then our third one. I'm just copying the signs that I see off of our original problem. I already know that I'm not going to have an x in my GCF because I don't have x's in all 3 of my terms. Let's look at our three terms here. And I need a number this time that divides into all three of those numbers, the 40 and the 36 and the 8. 8, does 8 go into 40? It does. Does 8 go into 36? 36 divided by 8 is 4.5. Not quite, not quite. So 8 doesn't work. 8's too big. 4 goes into 40, doesn't it? 10 times 4 is 40. 4 times 9 is 36. That works. 4 times 2 is 8. So we're going to have a 4. We can divide all of these by 4 and get whole numbers. So 4 in our GCF. And any x's in our GCF? No, because why? Because not all of our terms have an x, so we can't divide by any x's. So it's just a 4. All right, so let's see here. What is 40 divided by 4? 10. And we have an x to the 7th there. So 10x to the 7th. And I had already put my minus down from the original problem. 36 divided by 4 is 9. We've got an x squared there. 8 divided by 4 is 2. I can do a quick check and make sure we get back to our original. 4 times negative 10x to the 7th is negative 40x to the 7th. Yes. 4 times 9x squared is 36x squared. Yes. 4 times negative 2 is negative 8. We nailed it. Nicely done, guys. Good team effort there. Question? Yes, please. I'm sorry. Yes, yes. So this is a little bit more advanced, but in all of these problems, you are allowed for your GCF to be negative. It can be negative. So you had asked a minute ago about some alternate ways to do it. If I had a -4 in front instead, and this is a bit more advanced, well, we could make this work still, right? Now, what would I need to have inside of here so that when I multiplied -4 times this, I got negative 40x to the 7th? I would need a positive 10x to the 7, right? And here, -4 times, I would need a negative 9x squared. And here I would need a positive 2. So if I make the GCF negative, then that flips the sign on everything else. So this is an alternate answer. So a minute ago, Hayden, when you were asking about alternate answers, there are some alternate answers to these. Which one is more correct? What a great question. They are both equally correct. Now, sometimes when you get into algebra 2, when you get into some more advanced problems, there are a lot of times when you want to have the negative in the front, but sometimes you don't. So it just depends on what you're trying to do with it. So for today, we're just learning it today. I would recommend that today that you just stick with a positive GCF for today, but know later on that you can use a negative instead. If you flip the sign here, then you have to flip the sign on everything here. Okay. That's a great question. Thank you very much for that. Okay, one more together, and then I'm gonna have you guys practice now. If you're feeling good about this, feel free to ignore me and move on. Let's look at this. I'm gonna have a GCF on the outside of my parenthesis, and it looks like 3 terms on the inside. 1, 2, 3 terms on the out, and the original problem. So 1, 2, 3 on the inside. I'm gonna use the same signs that we had in the original. I'll just copy those into the inside. So negative, plus, and plus. Chris, you're with us? Don't miss us, please. All right, now, am I going to have some A's on the outside this time? Yes? Yeah. No? Do I have A's in all of my terms here? Yes, we do. So how many A's? Let's take care of the A's first. What is the most number of A's that I can pull out of each and every one of these terms? 5. I can get 5 out of here. I can't get any more than 5 out of there. I've got plenty to get 5 out of here. I got plenty to get 5 out of here. So we're going to have an A to the 5th on the outside. Now let's think about our numbers. Look at that 6 and that 4 and that 3 and tell me, what is the biggest number that you can divide all three of those by? 6 and 4 and 3. Nothing bigger than 1? What about 2? Oh, 3 doesn't divide by 2. All right, we want a whole number answers though, integer answers. So you're right, 3 does divide by 2, but it's not an integer. What about 3? Oh, 4 doesn't divide by 3. Bummer. So I guess it's just 1. So we could write the 1 out here, or we could just write a to the 5th, but basically we're dividing by 1a to the 5th in each of these. Well, that's going to make our answer pretty easy then, right? 6 divided by 1 is just 6. Now help me out here. What is a to the 13th divided by a to the 5th? What am I going to do with these two exponents? When we divide, what do we do to the exponents? We subtract them. Thank you. 13 minus 5 is 8. Let's see here. 4 divided by 1 is 4. A to the 6th divided by a to the 5th is a to the 1st, because 6 minus 5 is 1. Here I got 3 divided by 1, that's 3. A to the 5th divided by a to the 5th, those kind of just cancel out, so it would just be 3. And that would be our final answer. This 1 right here, we don't need it. Usually we would not write that 1 in. All right, so now that we've seen a few of these, I'm going to give you about 5 minutes, and I would like you to tackle as many as you can from 9 to 16. If you finish 9 to 16, feel free to start the next block of problems on the back side, but do not go beyond, sorry, mine are different. Do not go beyond number 18, okay? So see how many of these you can get done. There's 8 down here. See if you can get at least 4 done in the next 5 minutes, okay? I'll give you answers in a minute. I'm going to circulate around and answer some questions. I'd be happy to go over another one with you if you need. Okay, 10 more seconds, and then we're going to talk about something really important. Okay, let me get everybody's attention for just a moment. I want to talk about my favorite mistake that I saw on this. You're good. I'll show you this when you come back. I want to talk about my favorite mistake that I saw, and it was on number 16, and I saw a couple people do this. Please don't miss this. This is really important. So I saw a couple of people look at this and they noticed, okay, first of all, there's no X to bring out here. They started thinking about what goes into 40 and 32 and 48. And I saw several people say 4 goes into all of those. And that is true. 4 does go into all of those. So our GCF could be a 4, maybe. And if I divided all of those things, 4 divided by 40 is 10. We would need the X to the 3rd to stay. Plus, make sure you're taking the pass when you go. 32 divided by 4 is 8. I would still keep the X. 48 divided by 4 is 12. Hey guys, please stop the conversation and pay attention. Thank you. Now, this is not like really, really, really wrong, but there is a small mistake in there. And what is the small mistake? What's the small problem that we have here? So 4 is a CF. It is a common factor, but it is not the greatest common factor. There is something bigger. Now, the reason I was able to spot this right away, please don't miss this, guys. When you look at your answer, look at these numbers, 10, 8, and 12. Can you think of a number that divides into 10 and 8 and 12? If you can answer yes to that, then that means that this is not the GCF, it's just a CF. What could we divide 10 and 8 and 12 by? We could divide them all by 2. So check it out. I don't have to restart this problem. I can just go divide by 2, divide by 2, divide by 2. And then what do I need to do to this to fix it? If I'm dividing all of these things by 2 to even things out, what should I do to this? We're going to multiply it by 2. So then it comes out with 8 this would be negative 5x to the third, this would be 4x, this would be negative 6, and now it's the correct answer. Now, a lot of you probably recognize that the GCF was 8 right away, and you probably went straight to this. But even if you didn't, there's still a way that we can fix it. Okay, so always check on the inside and ask yourself when you get to the end and you think you're done, say 5 and 4 and 6. Can you think of anything I can divide 5 and 4 and 6 by other than 1? If the answer is no, then you're done. You did find the GCF. But if you can come up with something else to divide them by, go ahead and do that and then just multiply on the outside and take it one step further. All right, you guys did awesome with that. Let's flip over on the back side of our notes. And I want to review for our intermission here. I want to review multiplying binomials. So in number 17, what you got here, this is called a binomial because it has 2 terms inside each of the parentheses. So I have 2 binomials here. Folks, I need your attention for this. Now, I know that many of you had a different Algebra 1 teacher first semester, and that some of the Algebra 1 teachers taught some different ways to do this, but I need you to follow this method just for these 2 problems because you need to know how to do this, okay? We're going to be using the box method on Wednesday when we get to some new stuff. So I know some of you, this isn't your preferred way, but I need you to do it for at least these couple problems so that I know that you know how to do it. So go ahead and let's draw this box. Okay, I know for a fact that some of you like to just draw like the little arcs up above and below, and that's fine. You can do those problems that way, but you're going to need this box for what we're doing on Wednesday. So let me remind you how to do it. So you draw a rectangle and you draw 4 little window panes inside. And we're going to basically be finding the area of this box. Now, this top of this box is going to have an x and a negative 6 in it. That's the dimensions of the top of my box. And the side of my box is going to have an x and a positive 3 in it. So we're just transferring the 2 things that we're multiplying into the dimensions horizontally and vertically. Yes?
Does it matter when they then the first 2 numbers?
Oh, that's a great question. Thank you for asking. Did you guys hear that? Does it matter which one you put on the side and which one you put on the top? Does anybody know the answer to that question? Could I have put the x and the 3 and the x and the negative 6 like that? And the answer is yes. Either way is fine. Either way is fine. So whatever you're most used to, and some people, instead of putting the thing on the top, they'll put it on the bottom instead. That's fine as well. As long as you're drawing a rectangle, one of these binomials is going on the side, one's going on the top. Do you guys remember how to fill in the inside of the box? We're going to multiply. The key is multiply. So x times x is x squared. X times negative 6 is negative 6x. 3 times x is 3x, and 3 times negative 6 is negative 18, I believe. And then we just have to transfer that to our final answer. Let me give you a moment to get the inside of your box filled out there. For our final answer, we're going to take everything from the inside of our box, but we'll combine like terms. So I look at this, I see an x squared. I don't see anything I can combine that with. So I'll go ahead and bring that into my final answer. By the way, we should always start with the biggest exponents when we're doing this. Next up, I see a negative 6x, and I see a 3x here that can combine with it. Those 2 are like terms, aren't they? 3x and negative 6x. What would I get if I combine them together? Positive or negative 3x? If I combine these together, negative 3x? Yep, so minus 3x goes in here. And then, so I've already taken care of both of my x's. All I have left is this minus 18. That doesn't combine with anything, so that'll go into my final answer. So 3x squared minus, or sorry, x squared minus 3x minus 18 for my final answer there. Can I get you all to try number 18 on your own there? I'm going to work through it silently as well. Please use the rectangle method that we just used on number 17. And write your answer right next to it, please. Feel free to look up here if you need a hint, but try to do as much as you can on your own. Okay, we should be getting pretty close here. Were we able to come up with x squared plus 12x plus 35? Yeah. All right. Okay. So we've already done this once today where I flipped the table on you and I made you go the opposite direction. We're going to do the same thing here. So look at 17 and 18. Notice in both of these, I'm starting with two sets of parentheses. Each one has two terms inside, and I'm ending with a trinomial, something with three terms. Our goal in number 19 is to go backwards. We're going to start with a trinomial and we're going to factor it into two binomials. Now, I'll tell you that the process for doing this is a little bit complex, but once you figure out the process, it's pretty easy to do, especially if you've been doing your job and doing our homework. Do you guys remember those diamond problems that we've been doing since, like, I think it was literally on the very first homework assignment you ever did in this class. You did some diamond problems. And I told you back in semester one, and if you had a different teacher, they probably told you as well. These diamond problems are important because there's going to come a time at the end of the year where we're going to use this to solve a problem. This is it. Today, I'm going to show you the reason we've been doing those diamond problems all along. Okay. So we're going to use diamond problems to do this. Now, if you have not been doing a lot of your homework and you haven't had a lot of practice with these diamond problems, this may take you a little bit longer. For those of you who are really good at doing diamond problems, you're going to find this super, super easy. All right, so let me show you how this works. To start off, we're going to need some values for A, B, and C. That comes from our original problem. We are always going to start by making sure we've got numbers in front of each of our terms. There is a number in front of this m squared. It's not visible, but what is it? What could we write in here? 1. You all know that there's a little invisible 1 there. And that is going to be A. So A is 1. So A is whatever number's in front of your m squared or your x squared or your p squared. Would anybody like to guess what B is going to be? Make a guess, just a wild guess. 2. So I heard someone say 2. 2 is very close. Make a small modification to it. It is -2. See how there's a -2 in front of this m? So B is going to be -2. Who wants to be brave and guess what C is going to be? What do you think? It is -24. Do you see where we're getting A and B and C from? Are you guys seeing it? Prove it to me. Show me on number 20. Can you find A and B and C for number 20, please? Lazy with us? Yeah. See if you can find A and B and C for number 24 for me. I'll give you a clue. A is not visible. It's invisible. What is A? A is 1. Yeah, there's an invisible 1 in front of that p squared, and that would be our A. What do you suppose B is? Good. I'm glad you said the negative with the 13 also. That's a common mistake. Did anybody just have 13 without the negative? Anybody make that mistake? If you did, that's good. You got it out of the way. Don't make it again. And then C would be 42. Okay. Are we feeling good about getting A and B and C? That's step one. Step one, find A, B, C. Step two, build your diamond problems. So we're going to, right underneath here, I'm going to draw my diamond. I usually just draw the X. Now we're going to put numbers in the top and the bottom of our diamond problem. In the top, we are going to put, now don't write this too big, really small. A times C goes in the top and B goes in the bottom. We're going to put some actual numbers in though. So A times C goes in the top and B goes in the bottom. So what are we going to put in the top? What is A times C? That'd be 1 times negative 24. Negative 24. That's ours. Yeah, thank you. We didn't have another one come in, but thank you for bringing it back. I appreciate it. Someone must have left the restroom pass down there. It's back. And what is B? B is negative 2. So step 2 is to build the problem. Could you all do step 2 for number 20, please? Could you build me a diamond problem where you have A times C in the top and B in the bottom? Put some actual numbers in there. So figure out what would A times C be. Put that number in the top. What is B? Put that number in the bottom. I'll put 42 and negative 13 in there. Nice. Okay. So step 1, find A, B, C. Step 2, build the diamond problem. There's 2 more steps, guys. 2 more steps. You got this. Step 3 is to solve the diamond problem. Figure out your side numbers. Now, for those who've been practicing the diamond problems along with the homework, you know that the top number we're going to multiply and the bottom number we're going to add. So find me 2 numbers you can put in the side here and here that would multiply to give you negative 24 and add up to negative 2. Multiply to negative 24, add up to 2. I'm going to try and write down the different ways I can get 24 up here. 1 times 24, 2 times 12, 3 times 8, 4 times 6. That's it. So which set there that could I use? Now one of them is going to have to be negative. So 6 and 4, I think we can make that work if we make the right one negative. Which one needs to be negative? So they add up to negative 2. 6, we want the 6 to be negative. All right. Let me go ahead and show you the last step here because this is the easy part. This is the easiest part of the whole process. You ready? Here's my final answer. My variable was M, right? My variable was M. My final answer is going to be M minus 6 and M plus 4. And that's it. M minus 6 and M plus 4. All right, so let's see if we can finish up number 20 together. So see if we can solve this. I need 2 numbers that multiply to 42, add up to negative 13. What do you got, Chris? So 6 and 7 will multiply to 42. If we want them to add up to negative 13, I think they both want to be the same sign, right? If we're going to multiply to be a positive number. So is it negative 6 and negative 7 or positive 6 and positive 7? What do you think? We want both negatives? Excellent. So negative 6 and negative 7. Now check it out. I'm going to write the final answer. This is the easy part. This is a P problem. So parenthesis P minus 6 and parenthesis P minus 7 for my final answer. So the last two steps are kind of the easier ones. You do the diamond problem, you use those side numbers to write the answer. Now, before we go on, I want somebody to ask me a question about this answer here. I've had several people doing a really good job of asking me, could the answer also look like this? Does somebody want to guess another form I could put this final answer in right here? What do you think? We could switch the two. So I could have written my answer p minus 7, p minus 6, and that would also be correct. So it doesn't matter what order those two factors come in. We've already learned that about our diamond problems, right? When we're filling in the side numbers on the diamond problems, it's okay to flip those, which means it's also okay to flip our final answer. All right, let's do one from start to finish together. We're going to do number 21. So all 4 steps in one problem. All right, so first of all, see if you can find me A, B, and C. A, B, and C. So for 21 here, let's see, A is 1, B is negative 13, and C is 40. Hey, come on. Let's make our diamond problem. On the top of our diamond problem, we want A times C. That's 1 times 40. That's easy. That's just 40. And on the bottom, we want B, which is negative 13. Now, I just need to think of 2 numbers that are going to multiply to give us positive 40 and add up to negative 13. 10 times 4, that's not going to give me 13 though. 5 times, 5 and 8 might work. 5 and 8, you want them both to be negative? All right, so negative 5 and negative 8, so that's it. So then all we have left to do is write down our final answer. This is a P problem, so it's going to be P minus 5 and P minus 8. If you're feeling confident and you want to move ahead from me, that's fine. I'm going to do one more with you, and then we'll have some time for you to practice this. Seems like you guys are doing a pretty good job with this. I'm impressed. All right, last one together here. A is 1, B is 3, C is negative 18. A times C on the top, B goes on the bottom, so A times C. And then B goes on the bottom. I need to come up with 2 numbers that are going to multiply to give me negative 18 and add up to 3. 2 and 9, no. 1 and 18, no. What do you think? 6 and 3 will work. One of them needs to be negative if they're going to multiply to give me negative 18. Which, you want negative 3 or negative 6? They need to add up to positive 3. So we want the bigger one to be positive. So negative 3. All right. So then final answer, we're going to have X, make sure we got to put your plus in here, X plus 6, because that's positive 6, and X minus 3. X plus 6, X minus 3. All right, folks, I'm going to give you about another, let's say 8 minutes here to get as many of these done as you can. If you do finish early, let me know and I'll give you the assignments. I'll put up answers in a moment so you can check and see how you did. Okay, we'll come back together in about 8 minutes.